Wow, that's great.
Well, it did care. It just cared in a different way. You know, what was happening, I'm going to start the recording here. What was that? It was probably laying out memory differently so that the part of memory that was being overwritten was in a different place before, and it affected things differently. I mean, it still was weird things were happening, but in the current situation, the way the compiler laid it out, it was manifesting itself in a way that was more serious, I guess.
Yeah.
But so I dimensioned that array out, and that seems to have solved everything. I think all of the other fixes we've put in over the last how many years probably don't even need to be there anymore.
Now I don't have that. Now my QG Omega is not working, so I got to go back and check that. I don't know if that's really the same element or not, because I'll have to check it out.
Like I was telling Greg, we've been having some issues the last several days with data not coming in timely. The lags start getting big and we start losing data. I'm gonna have to contact the help desk because it's starting to get old.
Okay.
I mean, you'll notice if you look at the current radar, we're behind on radar data. Some of the satellite loops are a little glitchy because data comes in late.
Angela had communicated with me. She was going to talk about the hail in Texas to start the discussion off.
Okay, she's not here yet. Angela is calling me. Hello. Hey. Yeah. Okay. Okay. If you're able to get in, let us know. Otherwise, I'll communicate that because I'm talking to people on WeatherWatch right now. And which was your student that was going to present? Alex Raw? Tim Calamari, there I see him on.
Yeah, I was gonna say it should be me.
Okay, good. I'll okay. Okay. If you are able to get on the YouTube stream, go ahead and put comments on there because I'm monitoring those too. All right. Sorry. Yep. Bye. That was Angela Rao, and she said their home internet is completely down and she can't get on to do anything.
Okay.
She's going to try and follow along on the YouTube stream on her phone, but she said her cell service at home is pretty poor also. So okay. I guess we're winging it.
All right, I'm going to start then. I have stuff for the current weather, so that was part of our plan. I just missed the hail stuff.
Yeah, if she's able to get on later, I said just join and we'll deal with it then. If her stuff comes back up.
So Tim, when I'm all done, I'll stop sharing my screen and you can jump in with the
Perfect.
Okay.
Yeah.
Okay. All right. So let's see. I got to share this one here. And where is it? Oh, there it is. Okay. Okay. Welcome to our weather discussion for today. I'm going to do a few things about the current weather and then turn it over to Tim Calamari, who's going to talk about the forecast. And maybe if the internet gods are cooperative, we'll have Angela Rao come in and tell us about some hail event that occurred over Texas in the last couple of days. So this is a satellite movie over the continental US, and it's adjacent waters here from the infrared from the last several hours. I think it ends at what time? 16:30 GMT. So it's been a kind of an interesting week around the country. There's been one disturbance after another making their way across the US. There's one that's on the far extreme right of the image here that's to the southeast of the maritime provinces. That's been more or less stationary for the last couple of days. And then there's another disturbance that you can see kind of nicely organized affecting parts of southern New England. I'll say a little bit more about that as we move forward. There's heavy wet snow in southern New England today, so a pretty wild day in the New England states. Then there's some convective activity along the Gulf Coast, especially along the Florida Panhandle today. Some also in central Oklahoma that we'll see a little bit about. I'm not going to say too much about that. I have a suspicion that Tim's going to tell us something more about that. If not, it'll be in the forecast. And then some precipitation across, especially western Nebraska and parts of eastern Colorado and western Kansas. Some sort of upslope. It's quite an interesting day up there. Some at least light snow widespread over the far western plain states. And then the West Coast is crystal clear. They've had some beautiful days. We had a teleconference, Dave and I had a teleconference yesterday with Ellen McLatten up in Oregon, in Portland, and it's been a dry month. in Portland, which you don't usually say April is a dry month in the Pacific Northwest, but thus far it has been. Fire danger is rather high there now, and beautiful day again today in terms of fine weather. And then we've got some really interesting stuff going on in the Western Pacific, and I'll show just a little bit about that to round out the discussion. So as I've liked to kind of gone this way, I go from the satellite movie over the continental US to Alicia Bentley's analysis, GFS map. And this is at 060. I'll go ahead one time. So this is from 12Z this morning. And you can see in the black are sea level isobars, and then thicknesses in blue, everything below 540 decameters, and then in red, everything above it at 60-meter intervals. And then finally, the shading is 250 millibar wind speeds. So there's a pretty intense jet at 250 across the southern states. And that's really the jet feature of interest across continental North America at the 250 millibar level, fairly weak. Polar jet over the chain of lakes in Canada, and then a deep trough in the geopotential, in the thickness field, and with the trough on with the jet on the western side of it off the Pacific Ocean, off the Gulf of Alaska. And look at this cyclone. The GFS had trouble figuring out what to say about the sea level pressure field. It's pretty intense right there in Massachusetts Bay. We'll see a little bit more about that a little bit later, but a nice thermal structure to it too, especially the cold front is nicely organized. The warm front's rather poorly put together, but there's a occluded thermal ridge looking structure there as well. I'm not sure if that has much to do with the precipitation there. And here's the radar across the country currently. And Pete, I think, had mentioned there's some, to me privately, there's some data issues with some of our data streams this week. I noticed that earlier this morning. I'm not sure I'm noticing it now, except for that little blip. But there's some convective activity across eastern Kansas, eastern Oklahoma, crossing into Arkansas. I'm not sure how intense it is. Some parts of northern Louisiana have some pretty decent reflectivities into the 50 dBz range. So maybe hailstones at least. I don't know if there's anything more than that. And then along the south coast of Louisiana and the western panhandle of Florida, you can see some pretty intense convective showers moving across the Pensacola, Apalachicola area. And they're maybe decreasing a little bit in their intensity, at least in terms of the reflectivity at the end of this loop, but it's still probably a pretty active day over the Florida panhandle. And then look at this really interesting precipitation feature in the eastern United States, especially the New England states. This is clearly the western edge of a fairly intense cyclone that's out over the ocean. And much of this precipitation is falling as snow, not all of it, some mix of rain and snow. I'll show you a map in just a minute to indicate that. And but middle of April, we've had a pretty warm start. The first week was remarkably warm. The second week and a half has been kind of a little bit below average. So we're kind of right in the middle, probably 6 or so degrees above average at this point for the middle of April. You might see in the forecast, I talked about it today in my 100 class, we don't really have an escape valve from this for at least a week. It looks like it's going to be chilly, probably colder than normal for at least the coming week, get us all the way to the 24th of April or so before we even have a chance of anything changing. And that's going to itself be a relatively chilly day. So this is indicative of where we still are on the calendar. We're not out of the woods yet for the winter. I think we may not have any accumulating snow in Madison this April for the first time in 3 years. Nonetheless, it's downright chilly the last several days. Here's the map of New England surface obs. And this is now a couple of hours old, unfortunately. I was distracted by something else just before the weather discussion, but I don't think too much has probably changed in terms of complexion. But you can see the influence of not only the circulation around this storm. Look at the winds inland are all northerly or northwesterly, and then the ones on Cape Cod, you have a southerly wind at Martha's Vineyard. You have an easterly wind, or a westerly wind at Martha's Vineyard and easterly wind at Provincetown. So the cyclone center is right about in here, 990 millibars indicated by the observation at the Chatham, which is right on the elbow of Cape Cod. But it's not often you have 180-degree wind shift over, I don't know, probably 70 or 80 nautical miles, and the wind speeds are 25 knots on both ends, north and south. So that's a pretty intense little vortex. And light snow in Boston, heavy snow in Worcester. There was another place with heavy snow up near in Londonderry, New Hampshire. Rain along the coast of Maine. There's not many people living here, so no observation sites in interior Maine, but you've got moderate snow in parts of right along the border of New Hampshire and Maine, light snow in Burlington, light snow in Linden, and light rain in Burlington, and then some snow in northern New York. So there's several stations. It's mostly a southern New England thing where it's snowing today. I don't know if it's accumulated much there or not. And as soon as you get further to the south, the temperatures are 10 and 15 degrees warmer. So that's kind of an interesting weather feature for today's map that I thought was worthy of discussion. How come I can't get next to my, here we go. And now let's go to some upper level charts. What happened? Oh, okay, sorry. Here we are. Something happened on my screen. So here's the 12Z analysis at 500 millibars from this morning. Big ridge on the North Pacific Northwest coast, and that's of course consistent with the clear skies that we were able to see there on the West Coast satellite image, obliquely though we saw it. And the very intense upper level cutoff sitting this morning over northeastern Pennsylvania, 50-knot winds on its western side and 150-knot wind here at Albany on its eastern side. So a pretty intense upper disturbance and fairly cold air aloft. I think I see a minus 30 there at in around New York City at 500 millibars. Let's zoom in a little bit. Yeah, minus 30. So, that's pretty darn cold. And so you've got a pretty cold upper level low sitting there, and it's, causing some interesting weather as a consequence. We had a convective line in eastern Oklahoma moving into Arkansas. That seems to be downstream of this region of curvature, and upstream, or maybe exactly coincident with this ridginess that's downstream. So there's a lot of curvature in the flow in that location, which I'm sure is inducing some ageostrophy. And I should note that our cyclone in Massachusetts Bay is downstream of this pretty tightly curved upper level flow here as well. And anticyclone centered over the Intermountain West, over Idaho, parts of Montana, and northwestern Wyoming is a result of being downstream of this big upper ridge. And the light snow that was falling in parts of Colorado, western Nebraska, western Kansas is probably upslope snow, because if you've got a surface anticyclone about in this location, northern Wyoming, with clockwise flow around it, all the flow on the southern and southeastern side of that anticyclone is going up the slope. And it's not particularly warm in the central and mountainous central part of the United States today. So upslope flow combined with, chilly temperatures has produced widespread light snow across the central plains and into the Rocky Mountains at the latitude of Colorado and Wyoming. So that's an interesting situation there as well. Let's take a look at the 850 millibar map. And I won't zoom in on this, but you can see we saw in the thickness field on Alicia Bentley's GFS analysis that nice thermal ridge that came right into this fairly intense low-level cyclone. And we're seeing the same type of structure at 850. Here's a big thermal ridge in the isotropes in red, right into the center of that disturbance, which is right off the Massachusetts Bay. So, and look at it, you can see 180 knot wind shift between Portland and Chatham here at 850. So this is a really intense little vortex. And as I've already mentioned, snowing in places that probably have had enough of that for this year. I certainly, Michael's not here today, but I would wholeheartedly endorse a prohibition of any subsequent snow at this point, April 16th. I'm going to the Brewer game on Sunday. I don't want to see any snow anymore. I'm done with it. So, okay, there's 850. Let's take a look at the meager 300 millibar jet picture. I think it's kind of weak. Well, this one we'll see even stronger at higher elevation, but this is a weak little jet, 101 knots over the chain of lakes. This is the feature on the downstream, on the upstream side of that upper trough in the Gulf of Alaska. And that's really about it for jets at 300 millibars that are at or exceeding about 110 knots. We're not really in a particularly energetic period over much of continental North America. The southern states a little bit different, and it's more interesting to go to a higher elevation. So we'll go to 200, where you can see this is a pretty decent subtropical jet with a connection out to the central Pacific, most likely. And so this is a pretty zonal subtropical jet going right across the southern states, 121 knots over parts of the Red River Valley and then the border of Arkansas and Louisiana. So pretty nice upper flow well to our south, and only meager mid-latitude jets further to our north, and not much waviness in the flow here either. So, continued relatively boring weather, it seems, will be the case for us. Then I want to show you a movie that I found today of Typhoon Suragai, which is just absolutely spectacular movie. So let me just point out what's on this chart. We've got hind not casts, but Hein descriptions. What was this thing? Severe tropical storm, then finally a typhoon at 1 p.m. yesterday. And then it's going to turn into a strong typhoon. In fact, the SIMS page, which I'll show in a minute, has it going up to category 4 at one point in the forecast on Saturday, I think. And so, but here's a beautiful satellite movie of Surugai, and it's already made its way past Palau, and it's on its way to the Philippines. And you can see it's kind of got a nice looking structure. There's no particularly obvious eye at this stage, but when it gets at about, this location, Saturday, Sunday, it's going to be in the category 4 range, at least category 3. And so very intense cyclone. It'll be nice to look at this over the weekend and see whether or not, it presents itself nicely on the satellite movie or not. I think this is the SIMS page. This is just to give an idea of what the forecast looks like for Surugai. Category 2 maybe later today, category 3, and then heading into category 4 for how many hours? So for an entire day. So all through the day, Saturday into Sunday morning, when it makes its closest approach to the Philippines. Luckily, it doesn't currently stand to make landfall, and that's good news. Category 4 hurricane in mid-April is not unprecedented in the Western Pacific. I don't know that much about it, but I did a little bit of research on that. So it's not unprecedented, but it's still unusual and certainly noteworthy that it comes this early this season. So pretty intense storm for sure, and one that will bear watching. And then I wanted to just point out, sometimes these tropical cyclones can have, and maybe these early season tropical cyclones have a better chance of having a substantial and impactful interaction with the mid-latitude or subtropical jet, because both of those features are at their farthest southern latitudes about this time of the year. Well, actually, probably mid-February, but they're only gradually moving more poleward by the time you get to mid-April. And so I wanted to just take a look at whether there seems to be any of the basic ingredients for a substantial interaction between the hurricane outflow and the jets over the Pacific. So to do that, I'm going back to Alicia Bentley's maps to show a couple of different things. So this is valid right now. It's a 6-hour forecast from the GFS. And there's Surugai. And here is the jet off of Asia, or actually over Asia. It's over China and parts of Eastern China. And there's Japan. So if we go forward every 6 hours here, you can see the hurricane in the sea level pressure field moving along and east of the coast of the Philippines. And what happens is there's a really big development in the Sea of Japan, which I think was tied to this original jet feature coming off the continent. I am willing to bet that a 25-ish degree separation or a 30-ish degree separation of latitude means that this development is more or less independent of Surugai. That's not the kind of interaction I'm talking about. I was hoping that we might see the jet really get revved up as the big plume of low PV boundary layer air gets thrown out to the north by the hurricane. We don't really see that reflected in the ice attacks, which are shaded here at 250 millibars. And there's some particular reason why I think there's not much interaction, and I'll show you that in just a minute. The interaction that does build the jet has to be based upon, strengthening the PV gradient at the tropopause, which that will require the outflow is actually working on a substantial PV gradient, and it impinges upon it. It just looks like the spacing and the timing, the phasing here is wrong. Look at where the hurricane is, and there's this ridge in at least the thickness field, which one might guess is coincident with a region of pretty low PV near the tropopause over China, Vietnam, and Southeast Asia. And that's kind of where one might expect the influence of the hurricane to really have some impact. So let me show you what I mean when I say I think the timing is wrong. You can see the cyclone. I'll just go through that again as it marches toward the Philippines. In this forecast, it actually grazes the coast, but you don't really see an intense change in the jet structure. The only substantial mid-latitude development is that thing in the Sea of Japan. That's a pretty intense development, but that seems connected to the exit region of this jet that comes across the continent over the islands, and then it really develops. So let me show you a different variable. This is the 300 to 200 millibar PV in black contours. I'm going to go back in time. I hope that's where I'm going. Am I? Yeah, I'll go back to the initial time. The black contours are the 300 to 200 millibar PV in PV units. So like this feature right here, stretching southward from the Aleutian chain to the Central Pacific. That is coincident with the strong jet that we saw both in the 300 millibar map prior, and we saw evidence of that at 200 as well. So that's a strong jet region, and they're always coincident with strong PV gradients. Here's a little bit of a jet region, of course, coming across the southern states of our own country, coincident with a strong PV gradient. The weaker jet in northern Canada is still associated with a locally strong PV gradient. So that's always the way one can, connect what the tropopause level PV is looking like and why does it have any influence at all on the jet, because the PV gradient is where the jet resides. So here is the Philippines, and here is Surigay in its current state, which is about Category 1 hurricane strength. And these are the irrotational winds at 200 millibars that are coming out of the divergence features in the middle and upper troposphere and so on. So what you want to see is this irrotational wind have an impact on tightening the gradient of PV. If the hurricane outflow, which is a proxy for it is the irrotational wind, if the hurricane outflow serves to intensify the PV gradient, then it will serve to intensify the jet. So early on, when they're separated by 20 or so degrees, there's pretty much no chance that's going to happen. But as we move forward, the big extratropical development that goes on in the Sea of Japan in association with the jet exiting the continent has an enormous widespread field of irrotational divergence aloft, because this is a really intense development. But here's the hurricane. And so what you hope to see is that this PV gradient gets hit by these irrotational winds. But watch what happens. At least this is my first guess at it. Here's the weakest portion of the PV gradient in the entire environment is kind of coming right in place to be impacted perhaps by these irrotational winds. In fact, it gets worse. It's worse even back here over, the coastal China. Here's where you finally start to see some substantial irrotational wind associated presumably with the hurricane, but it's working on the weakest part of the PV gradient. So my sense is, and we talked about this a little bit last week because we were going to keep our eye on this interaction. My sense is that that the timing is just off. There isn't a strong initial PV gradient which can be made stronger by this irrotational convergence, because you can see these irrotational wind vectors get smaller. So they're pushing things together. They're pushing any tracer together, including the PV, but there's just nothing to push together there. And so my sense is that, look at that. That's a boring gap region in the PV gradient. And that's where all the outflow from Surigay is going across. It's not really doing any work. The main jet strong PV gradient is well to the east by this time. So it strikes me that though this is a really intense tropical cyclone, which presumably has a huge outflow, it's not going to have much impact on the mid-latitude or subtropical jet across the Pacific, just because it hits a bald spot in the PV gradient when it gets close enough to it at around 20 degrees north. So I thought that was kind of an interesting, I'm throwing it out as a conjecture, and of course we'll see whether or not this changes. This is still several days into the forecast. It's a 4-day forecast at this point, but if that remains the case, this is probably going to be a noteworthy tropical storm for sure, but not one that disrupts the mid-latitude predictability or the mid-latitude flow very much, as some of them can in both cases. So that's what I have, and I take any questions or comments, and otherwise I'll turn it over to Tim. Okay, I'll stop the sharing then. So Tim, it's all you.
Perfect. I'll get this screen shared real quick. Hopefully you all can see this. This is a similar satellite loop to what John showed earlier. Just giving a general overview of what the environment's looking like over the continental United States. We see this, whoa, I just lost everything.
I can't see your screen. It just tells me that you're started your screen sharing too, Tim. So I don't know what's going on.
Yeah, I'm seeing the same. Apparently the internet issues are not limited to Angela and AOS. There we go.
No.
Nice.
All right, maybe I'll turn my camera off then.
Yeah, that sounds good.
That might help. How do we do that? There we go. All right, hopefully that works. Can you all see this satellite image, I hope?
Yep, looks good.
All right.
Yeah, yep, can see that.
So yeah, as John alluded to earlier, we see this the strengthening surface cyclone right off the coast of Cape Cod, Massachusetts, continuing to develop and produce heavy snow and rainfall in the region, and we'll continue to see that propagate northeastward into the Atlantic Ocean. Another interesting feature I wanted to note before I got into it was this somewhat of a development of a surface cycle. You can kind of see a little bit of rotation as it's coming in the lee of the Rockies, as well as this very intense zonal flow in the upper atmosphere seen over the southern states through Texas, as you can tell from the satellite loop. Let me slide into my slides real quick. Oh. I have no, hold on one second. There we go. So I want to start off just with a general overview of the environment. This is the GFS model. This was initialized yesterday morning, and it's valid around this time, 11 a.m. this morning. But we could see the strong undulation off the Alaska coast and into the eastern Pacific with steep ridging and troughing associated with that. And as John also alluded to earlier, this strong, fairly sharp upper level ridge located just in southern British Columbia in Canada, with a very weak jet feature with maximums upwards of only 80 to 90 knots at 250 millibars. Another interesting note with that little deepening surface cyclone, we see this shortwave trough located in northeastern the United States, and we'll continue to see that deepen as this cyclonic vorticity continues to increase and drop heavy snowfall and ample amounts of precipitation that I'll get into later. Another interesting note was this zonal flow that we see here at 250 millibars. And it's just basically across the entire southern portion of the continental United States, just driving everything just straight across from west to east, which will definitely keep the surface cyclone I just showed in the earlier satellite loop from developing into not a very organized storm and having more of a widespread area of showers and precipitations as it progresses towards the eastern coast. So here I just want to show any difference between regional models. So this is the NAM model, initialized at the same time yesterday morning, valid around this time as well. And we still see this general zonal flow from the subtropical jet, seen here with magnitudes upwards of 120-ish knots, as well as the deepening of this low seen here at 993 millibars just off the coast of Cape Cod, which will just continue to keep producing heavy snow and rainfall up until it progresses following the flow pattern out into the northeastern Atlantic. And back to the west, we see from this upper level ridge in British Columbia, we see the jet diving down into the western US, producing cyclonic vorticity in the lee of the Rockies, which in my assumption is leading to the development of that surface cyclone that we saw on the satellite loop, which will then progress and is developing that precipitation throughout the Midwest near Kansas and Nebraska during this time. And then here, I just wanted to take a model run from this morning to see if there was any change from the model runs from yesterday. So this is the NAM initialized this morning earlier, also valid for right around this time. And we can see it's generally the same, maybe a little bit of strengthening in the cyclonic curvature of this upper level trough seen here in the northeastern parts of the US. Which could possibly allow for even deeper convection to be occurring within that storm. And we'll take a look at that later. But overall, the magnitude of this subtropical jet seems to be fairly steady and completely zonal from west to east throughout most of the portion of the southern states of the US. So now looking a little bit lower in the atmosphere, this is the NAM model initialized yesterday morning, and this is also valid for around this time. This is showing the 850 millibar geopotential height and vorticity. The first thing we notice immediately is just the strength and the magnitude of this surface cyclone in the northeastern part of the U.S. and how deep it's developed with that shortwave trough that we saw in the upper levels, just continually providing ample precipitation and deep convection to this region, providing heavy amounts of snowfall and rain and precipitation. And then as well, from what we saw on the satellite loop of that subtle curvature of the surface cyclone just in the lee of the Rockies, I was a little bit surprised to see a fairly limited amount of vorticity, cyclonic vorticity in this region, even though we saw a fair amount of it on the satellite composite, excuse me. And from here, we can't really pick up on much of that. And I want to say that might have something to do with the strength of that purely zonal flow from that subtropical jet, which we'll get into in a little bit. So now just looking down at the surface, this was also initialized. This is a NAM model initialized yesterday morning. And we see here, this is just the mean sea level pressure and precipitation rate. And we could see, again, heavy snowfall occurring with this surface cyclone with a low of 995 millibars just off the coast of the northeastern states, with rainfall just continually getting wrapped inside with this, what John alluded to with the thermal structure, continually wrapping in here with a very strong and deep magnitude of that surface cyclone. And then if we look back more towards the Midwest, we still see this surface cyclone that was seen on satellite. It doesn't have much of a great structure to it. There's not much organization to it. And as we'll see in future slides, this progression of storms never really develops into a normal structure of a cold front and a warm front associated with the mid-latitude cyclones. And so these two red triangles, I'm going to take soundings and show soundings later on, which will help show just the vertical structure in those regions. So one from central Alabama and then one from Portland, Maine up here. So here's the GFS model sounding from Portland, Maine. This was initialized yesterday morning and it's valid for just in the afternoon later today. And we could see surface temperatures near 42 degrees Fahrenheit. I was shocked to see because it showed and forecasted heavy snowfall to be occurring in this region with surface temperatures of 42 degrees Fahrenheit. I was surprised to see, and I'll show on the next slide, some of the model members showing upwards of 6 inches of snow falling in this Portland, Maine area, which is located, I think it's at an elevation angle of 62 feet above sea level. So elevation from the Appalachians had no effect on that. So it's very interesting to see that. And so I'll show this. These are just the SREF plumes from that same location up in the northeastern area where that surface cyclone has been continually deepening and strengthening. And we see some of these model members. I just want to show this because this was insane to see. Some of these model members showing upwards of 6 to 11 inches of snowfall occurring where surface temperatures were seen during this time to be 42 degrees Fahrenheit. So either this is extremely heavy snowfall with some just heart attack snow if you're shoveling that, or something's going on with a few of these various members. But on average, you see around about 2.5 inches of snowfall expected near Portland, Maine, just on the coast. And next, just hopping back over to the more of the Midwest where that surface cyclone was developing. This is from central Alabama, it's just sounding just before that storm was propagating towards it. This is initialized also yesterday morning, and it's valid right around this time today. And so we see a fairly well mixed layer at the surface, followed by a shallow dry layer right above that, just above 1 kilometer in the atmosphere in depth. But the main thing I wanted to point out here was just the wind shear, or the lack thereof wind shear, throughout the entire column of this atmosphere. I mean, from the photograph, it's just complete westerly wind shear with increasing magnitude given the height. But it was just astonishing to see that at each layer of the atmosphere, other than the first kilometer, let's say, just everything completely in westerly direction, which leads me to assume that this organization of that surface cyclone is going to have trouble developing, and it'll just continue to kind of smear all of that precipitation and convection across the southeastern states of the U.S., which we'll see in future slides. So now here we're just jumping ahead to 48 hours. This is a NAM regional model. This was initialized last night around 11 p.m. This is valid for Sunday around lunchtime. We could see first thing the subtropical jet having it propagated more towards the southeastern states now, still with similar magnitude of 115 knots or so, but still just strictly zonal flow. So not much interesting going on here. We'll just see once we get down to the surface, all of this precipitation that has propagated towards the east has just continued to stay disorganized and very widespread, producing not much extreme and severe weather, but mostly just widespread rainfall and just heavy amounts of precipitation all over. And the other thing I wanted to note on this 200 millibar wind speed map was this purely northerly flow coming out of the Alberta and Saskatchewan provinces of Canada, which we'll see in the coming days. This will continue to dive down south into the Midwestern states, into the northern Midwestern states of the US, and bring with it very, sadly to say, a lot cooler temperatures than normal for late April than we've normally seen. So just a very interesting setup here for late April. And now just looking down a little bit lower in the surface, This is the NAM model again, initialized from last night at 11 p.m. Also valid for Sunday around lunchtime, just showing the 850 millibar heights and wind speeds. The one thing I really wanted to point out, other than we've seen that this the deepening surface cyclone that was located in the northeastern states has already propagated north and east into Canada and off into the Atlantic Ocean by this time. And then we also noticed this oddly oriented shortwave trough seen here with almost northeasterly flow coming in from the Manitoba region and diving down into the North Dakota and the South Dakota regions, which we can expect to produce some sort of a surface low development in that region. And I don't want to say an Alberta Clipper-esque because of the time of year it is, but it shows to be somewhat of an Alberta Clipper track that it's going to take with this slowly deepening low pressure system that we'll see. So now looking down at the surface, this is the same time the NAM model initialized also again at 11 p.m. for valid at Sunday around lunchtime. And we could see that this shortwave trough that we saw at 850 millibars has developed into a pretty weak low right on the Dakota borders, just south of the Canadian border. And hasn't really organized much yet at this time. But we could see the steep drop off in the 1,000 to 500 millibar thickness, basically right over much of the Midwestern states, including Madison right here. And with this upper level trough shown, this surface low will then generally follow this track as it progresses right over Madison almost, and then on into the Great Lakes and on into the northeastern region again. Another thing to note was this convection that we saw earlier in the satellite loop. Even though this is 2 days in advance, there's no organization at all really, and there's still like convective showers and precipitation occurring across the southeastern states, but there was just no real definition ever. And I want to have to assume that had to do something with the magnitude and the purely zonal flow of that subtropical jet that we saw there. So this is moving forward about 18 hours. This is valid, same model valid at Monday morning around 5 or 6 a.m. And we see this low is strengthened a little bit as it approaches the Great Lakes region and just northern Wisconsin, as we see the development of its normal cold front and warm front signatures that we see. And with that shown, we'll show sounding from Madison for this time afterwards. But we could see it's continuing to follow this upper level flow pattern. And again, we could see just still scat, not really much going on in these southeastern states as far as organization with these storms. So just kind of widespread precipitation associated with that upper level zonal flow and associated trophiness of the upper level flow. So here's a Madison sounding. It's from the time just shown previously. So this is valid at Monday around lunchtime. We could see with that surface cyclone that's developing, that's progressing its way down and into the northern Midwest states. We see here with surface temperatures of 52 degrees Fahrenheit. We can expect mostly just rain with this, but then there is the associated snowfall that is forecast possibly to occur in the northern parts of Wisconsin with this. And so with this relatively weakly mixed layer at the surface and purely dry adiabatic temperature profile throughout the atmosphere, we could see this storm, the storm system just continue to progress and deepen while we go through on early into next week. So now showing, this is jumping forward. So this is valid. This is GFS model valid. Monday, right around lunchtime. This was initialized yesterday evening. And so we could see this subtropical jet that was purely zonal for the first over the weekend has now started to, not much curvature to it, but has started to turn a little bit towards the north. And with that, just continuing to drag this widespread scattered precipitation with it, and just continuing to dump a lot of precipitation across the southeastern states of the U.S. while driving all this moisture up from the Gulf of Mexico. And then again, we see the deepening of this upper level trough, upper level long wave trough, with the purely northerly winds coming out of the Saskatchewan and Alberta provinces. And we'll continue to see this deepen and push itself deeper and deeper into the Midwestern states of the U.S. as we get into the middle of next week and late into next week, bringing along with it much cooler temperatures than average. And we'll show some temperature anomalies with that later. So here we just have the same GFS model, initialized at the same time for, this is now valid Monday, right around lunchtime. And this is showing the 500 millibar height anomalies. And so we see with that upper level trough dipping all the way down through almost near Kansas, we could see these height anomalies dropping on the order of almost -20 decameters than compared to average, which, and we'll see soon that this won't get much better in the coming days. So next week, early next week, colder temperatures are going to be arriving with the onset of that low pressure system that at this time has already progressed into the Great Lakes and continues to deepen with the strengthening of the curvature of this upper level trough that we see. We also could note that an upper level ridge, I know it goes off the page here, but there's an upper level ridge developing at this level and upper levels that'll help give way to an extremely high pressure system that works its way on up into the Montana area and on into the Midwest come late next week, which will bring with much more dry conditions, as well as associated with these extremely cold conditions. It'll be fairly cold and fairly dry across most of the Midwestern states come middle and late of next week. And also associated with that, like more warm temperatures than normal for the Western states, as well as dry associated with that high pressure system that will develop, which, as John alluded to earlier, will not help their fire hazard and their fire danger risk that they currently already have right now. So the drought forecast for them continues to not look great, and we'll see an image of that later on too. So now here's jumping forward. This is GFS again, showing the 200 millibar height and wind speeds. This was initialized last night around 11 p.m. and this is valid for Tuesday around midnight. And so we see this subtropical jet starting to develop even more curvature to it, as at this time, this low pressure system that clipped through Minnesota and the Wisconsin regions earlier in the week continues to strengthen and almost takes on a similar path as to the one that John previously showed that was sitting over the northeastern states of the US. But this one takes on more of a Great Lakes track, and it pushes on northeast into Canada while it continues to deepen and produce ample amounts of rain and snowfall with that. But we continue to see the strengthening of this upper level trough as it dives its way down into the upper Midwest states and continues to bring with it much cooler than average temperatures, as well as this image is not a very good one. It's just this jet over the central part of British Columbia is very weak. The magnitudes here are just poor. So, but we will see the development of a high pressure system at the surface due to this anticyclonic curvature of the upper level jet stream, which again will give way to much drier conditions in the western and midwestern regions of the US come middle to late next week. So here, this is showing the same time. This is valid Tuesday, late Tuesday night. This is showing the GFS 500 millibar height anomalies. And so we could see this upper level trough has just continued to dive deep, almost getting down to Alabama. And we see height anomalies on the order of negative almost 25 decameters below what normally would be for around this time of year. And that bringing just extremely cold temperatures for what we would normally see, with some lows during some nights being like almost 25 degrees Fahrenheit, which is not something I'm looking forward to at all. And then again, a high surface pressure system that continues to develop and strengthen that we'll see in future slides that will just continue to bring dry and just clear air to most of the Midwestern region, as well as the western parts of the US as well. So going down a little bit more in the atmosphere, this is still valid for Tuesday night, right around 11 p.m. This is just showing the 850 millibar temperature anomaly, just to show how deep this trough gets and how much cold air it brings along with it. This just doesn't look fun. I mean, on the order of -10 to -15 degrees Celsius below average for this time of year across 60% of the states in the Midwest right now. So this entire thing bringing very, very cool temperatures and very dry temperatures, as we see with this upper level ridge, not shown on this map, but you could see, oh, excuse me, sorry about that. With the upper level ridge shown still stationed over British Columbia and the Alberta area, that brings the higher temperature anomalies more increased over the western regions, which again does not help their fire risk they currently have, along with the dry environment that the increasing high surface pressure system will bring. So here, looking at the surface, this gives a good view of that developing high pressure system. This is the GFS model, 1,000 to 500 millibar thickness and precip type. So this was initialized last night around 11 p.m. And this is also valid for Tuesday night. And so we see that Alberta Clipper-esque low pressure system that has passed its way through Wisconsin and into the Great Lakes region continues to deepen. Not too much of a strengthening storm as it continues to progress east of the Great Lakes and on into the northeastern states. But we do see the typical cold front and the warm front boundaries associated with that. And if we look back here, that upper level ridge seen now coming on shore at this time in the western U.S. Develops, at least on this plot, two high surface pressure systems that have values of 1,026 millibars. So it's extremely high pressure, just providing very dry and just cloud-free air to most of the Midwestern states, as well as a lot warmer temperatures to the Western states due to that upper level ridge that we saw earlier. So again, that fire hazard in the Western states is not looking very pretty at all. And we could expect a lot more dry conditions up in the northern Midwestern states come middle and late of next week, which we'll see. Actually, NOAA put out a tweet yesterday, which they showed just drought probabilities of increasing and decreasing. So we'll see that later on as well.
Excuse me, Tim.
Yeah.
Yeah, it looks like the if you go back to that map and the preceding one that showed the 850 millibar temperature anomalies.
Okay.
I mean, that's a really cold. That's pretty cold air at 850. And I imagine if we saw the actual temperatures, we could kind of project what the surface temperatures would be. And I imagine those are going to probably be in the maybe low to middle 40s, which is, I think, well below Clima. I don't know. Clima now might be mid 50s. I don't know. Someone knows.
Very cold, though. Yeah.
Yeah, I think
But
it's mid to high 50s, Michael. You're right. So it's
Right,
going
so
to
it'll
be brutal.
Yeah, 10 to 15 degrees Fahrenheit below normal. That's going to be pretty uncomfortable.
Yeah, unbearable. Not very excited for that at all.
Greg, how do your fruit trees do in that? They must have got an early start.
Well, not really. They're starting to come out, but they haven't blossomed yet.
Oh, well, that's good.
They seem to know what's going on.
Yeah, I guess they do. I'd have been fooled if I was a tree in early April. Would have been bad.
Sorry about that. My thing cut up. Yeah, but yeah, as you can see, just extremely across most of the Midwestern states too, just this extremely cold temperatures at 850 millibars. And yeah, I should have overlaid the actual temperatures at 850 millibars just so we can get an idea of what the surface temperatures are like. But low temperatures for Madison for next week during the middle of the week can get into the 20s and will not be very comfortable at all. So that is not something to look forward to. So moving on. So now I just want to show, these are just two, there's this image and another one. This is tweeted by NOAA yesterday. This is a 6 to 10 day outlook. This is valid for Monday through Friday of next week. This is just showing the temperature probability of how probable it is to be much more below average for this time of year. And you can see with this strong upper level trough dipping its way far into the southern states of the US, it's just, we're not in for a very fun and warm week. As you can see. And then again, this upper level ridge seen centered now over British Columbia for this coming week, we see the not extremely, but the warmer temperatures than normal in the western states. And with the associated high pressure system just shown before, and those dry conditions being brought to the western and central states of America, that will not bode well for the western states and their fire risk. And then this was the other image I tweeted. This was just the precipitation probability. I thought this was rather interesting because you could see in the southeastern states, as we didn't really see much of a development of that system and an organization of that system, we were able to kind of pick up that zonal flow of that subtropical jet just kind of continually produced just widespread scattered storms all throughout the Southwest, giving probabilities of 40 to 50% above average. And again, that that surface high pressure system that developed due to that upper level ridge seen in the western US just continues to bring dry air all throughout next week, as this is valid also Monday through Friday of next week. And so we just continue to see dry and very cool air in the upper Midwestern states, as well as extremely dry air associated with warmer air due to that upper level ridge in the western states. Yet again, that fire risk is not looking amazing for them. The last thing I also wanted to touch on was, John touched on it a little bit, but it was Typhoon Sergei. And this was phenomenal to see. I don't know if I remember the last time I've seen a strong typhoon develop this early in the Western Pacific. And it might be hard to see, but 18, so on Sunday at 0Z, so Saturday night, there's winds sustained of 115 knots with gusts up to 140 knots, which is just extremely impressive for a system of this magnitude and at this time of year. So it's very interesting to see. And also, as of now, as John also alluded to, it seems to be that this typhoon will not make landfall in the Philippines, which is good, as it's just kind of coasting along the east of it and just hugging near the side, which is a good thing, because with winds upwards of 140 knots, that would be very, very hazardous and detrimental to many portions of the Philippines there.
Speaking of that,
sorry.
oh, I'm sorry.
No,
Sorry to interrupt. Just speaking to the storm, one of the interesting aspects of it, unfortunately I missed John's discussion earlier, is how the new version of the GFS was forecasting an event of this sort, I think almost 2 weeks ago. And there was a lot of speculation when it first showed up. People were like, oh no, that's not going to happen. It's out to lunch. Then the ECWF came along with it. And just an impressive feat and worthy of trying to understand what were the elements that the GFS picked up on. I know about 2 or 3 weeks ago at Weather Watch, we were talking about, I guess, the emergence, or this may have been faculty on Twitter talking about the MJO beginning to erupt out over the Indian Ocean and progressing eastward. And I wonder if that had, that was a strong signal that portended some other implications over the hotspot of the Pacific for these tropical cyclones. But it's just an impressive feat of numerical weather prediction.
Yeah,
so 2 weeks out.
Especially at this time of the year too, in April. I mean, that's awesome. Then I just lastly wanted to show, this was just the hurricane warf for Surgai. So this was initialized yesterday night at 11 p.m. This is valid for just around lunchtime on Sunday. I thought this was just extremely impressive. A low of 927 millibars at the center of this thing. You could see the max winds of 121 knots at this time, just kind of hugging the Philippine coast, the eastern side of the Philippine coast, as it tracks its way up the coast. I just thought this was a really cool development and interesting system to look at. And with that, I think that is all I have for you. I will take any questions if anyone has any.
I'd like to say something. With that tropical cyclone, it looks like there's a very strong Kelvin wave formed near the maritime continent that's just starting to move across. It's a equatorial Kelvin wave, and it's moving across, and it's very strong upward motion right over the region where that tropical storm is. Or very strong minimum in the chi field of velocity potential. I think that has something to do with what's forcing it. And it's propagating eastward, and it looks like it'll be moving it's a struggle for this thing to keep developing, and then pretty soon it's going to lose the support because this thing is moving toward the east. But it looks like this Kelvin wave started over the maritime continent, and then it just propagating away, and the maritime continent is changing into straight sinking motion right now. So that's kind of interesting that it looks like whatever was going on over the maritime continent is starting to end, and in the wake of it, it's sending off this Kelvin wave toward the east, and that seems to have something to do with why this tropical cyclone's taken off. So thought I'd point that out.
It seems to intensify an extreme amount over the past 48 hours, especially. And I mean, it is forecast, as John said, to get into a category 4 storm. And thankfully, as of now, it's not forecast to hit.
I can show you, if I could take the screen for me,
Yeah,
I'll show you
course.
that Kelvin wave.
One thing I don't know about this hurricane development is there anything unusual about the sea surface temperature or ocean heat content in that part of the globe for this time of year? I haven't seen any, graphics of that or anything to suggest that, something as straightforward as that might be underlying this unusual situation.
I don't think so, John. I don't think sea surface temperature alone would cause this to happen. These are not instabilities of like a conditional instability or anything. There
Yeah.
needs to be some kind of a forcing. That's why the prog saw it so far in advance. And how do I get the screen?
I think at the top there or at the bottom, there's a share screen. You hit in the middle of that green square.
Oh, the
Yeah,
green. Okay.
you're a co-host, so you should be
I
able
think I'm
to.
unshared, right? Yeah.
Okay. Can you see my screen?
Yep.
Now we do. Yeah.
Okay. So this right here is the chi field aloft. And this is the J bubble, but don't worry about that. But this is the chi field in the blue. And you can see if I go back to yesterday morning, this thing was just starting to develop here, and it was still not quite red. There was still some blue over to the west in the maritime continent and all. And this is just starting to take off and move to the east. So if I go forward, this is at Thursday at 12Z. So this is yesterday morning, and go forward to right now. You can see this thing intensifying. And you can see the whole to the east or to the west over here. It's becoming all red, which means it's subsidence occurring. This is GFS solution here.
So this is it's the irrotational wind. So that's the blue is the divergence aloft. Is that what it is, Greg?
Yeah, this is a chi field. This is the velocity potential.
Okay.
And
Thanks.
Laplacian of this is divergence. Yeah.
Yeah. Okay.
So yeah, so this is the divergence. You can see here's where the tropical cyclone is in there. But it's over the tropical cyclone even up to a few days, but it's moving toward the west or toward the east. So and it kind of is doing this in each prod. See, if I go back and do today's, the one I have, the most recent one this morning, 6Z, you can see it doing the same thing. And it's definitely propagating to the east. So it definitely looks like a Kelvin wave. You see it centered at the equator as it moves east. So I think it's a Kelvin wave.
Yeah. Interesting.
So I think that's what's really forcing it. And, I think, the more research I do on this, the more I see that these things are really predictably forced. They almost always have something going on, especially the strongest ones that are causing them to be where they are when they are.
Yeah, and maybe the strongest ones at unusual times of year. I mean, as I mentioned, and Tim did too, this is not unprecedented, but it's unusual. And so if one were to collect a calendar listing of April and early May tropical cyclones near the Philippines, you might have a better chance of seeing such an undiluted signal in every single one of them, because there's nothing else that drives them at this time of year as a hypothesis.
Yeah. Oh, as long as I got the screen up here, I could look at this, show you the jet streams right now, which are somewhat interesting. This is that time of year that I kind of show every year when we have a polar night jet dissipating in the North Pole and a polar night jet just starting to form here at the South Pole. So we're exactly at the transition right now where the northern hemisphere is transitioning into the summer and the southern hemisphere is transitioning into the winter. And here's where you can see, if I go to the first frame here, this is 6Z this morning. Let's go to 0Z later today. This subtropical jet right here, these are the jet streams. This subtropical jet right here is where the forcing from hurricane, whatever, or typhoon, whatever his name is occurring. So you can see that forcing against a subtropical jet. But interestingly, it's not shooting any outflow up very far north.
Yeah.
Like you said, it just seems to be trapped. And if I go ahead in time, it doesn't really ridge anything up to the north. There's still this remnant of a polar night jet up here, or what's left of it. But it seems like all the outflow energy is being directed toward the east. And a little bit of the outflow you could see down here across the equator. And we see that a lot with these. And if you look at the satellite, you can definitely see that a lot of the flow is going south. And so I think a lot of the outflow from that typhoon is going into the southern hemisphere at this point. Probably divided up. I don't know if it's equally or whatever, but some of it's definitely going across the equator. And whatever that means, maybe that's indicative of this time of year that they, when the northern hemisphere and the southern hemisphere are both of similar transitional states.
Hmm.
Maybe it is more likely that the outflow can go in either direction. I don't know, but it does seem right now that this subtropical jet down here on eastern Australia is being forced to some extent by that typhoon. And
Yeah, that's
I've done these studies before, put tracers inside, and I do see this happens.
Mhm.
They said when you see those outflows going south, they go right across the equator and wind up in the southern hemisphere at the subtropical jet of the southern hemisphere. So I'm pretty sure that's what this is.
Hmm.
So anyway, that's all I have.
Yeah, that's neat.
And I'll give you your screen back if I can figure out how. Where is it? I lost the point where I know how to give it back. Am I still on?
Yeah. There's
I
a,
think-
I
I
think
think it
there's a
might be
button at the
just the
top that
top.
says stop sharing.
Oh, yeah, stop share. Okay.
Yeah.
There it is. I don't have that at all.
It's sort of
Okay.
like stop the steal, but it's stop sharing.
Sharing is something that's legitimate, though.
Yeah, that's right. That's true. We actually can share the screen. Well,
All
thank
right.
you, Tim. That was very interesting, and thanks for the presentation today. And Greg, thanks for those comments at the end. And Pete, of course, for organizing and being the gatekeeper. That's a useful and unfortunately necessary activity in our current state. And I guess we'll see everybody next week.
Yeah,
So-
thank you.